Hello students, Miss Walsh here. So here we are back for more mathematics of COVID-19, and you should have watched and taken notes on this video, Exponential Growth in Epidemics, by the 3 Blue 1 Brown channel, which is run by the mathematician Grant Sanderson. What a great video. I think this is a great way to make this very complicated topic in a very presentable way. Okay, so just what we're going to do is we're actually going to see whether we can apply what you learned from the video to our real data. Okay, so remember that he was talking about this growth factor. This is the same growth factor that you have already learned about in grade 8 and grade 9. It's your same problem of shoes used to cost 60, now they cost 75. Find that percentage change. This is the same thing. So very important to be aware of when you're looking at this statistics of COVID is sometimes the data is given as total cases and sometimes it's given as new cases. So do pay attention. This is total cases, right? This is not the curve that goes back down. There's no way the total can go back down. We have what we have from the start. In order for us to find the growth factor then from the total, we need to see, well, how many new cases are we getting? So it's the change in the total. And we compare it to what was the change in 1 day before, so D minus 1, okay? And he was also talking about this inflection point where basically here the growth is very, very steep. Here the growth factor is exactly 1, and then after that it starts to slow down. Okay, so let's take a look, and we're going to apply it in Excel. So I have my handy dandy spreadsheet here that I will make available to you as well, because you may want to explore some other countries and what's going on. Okay, so if you do, under this columns label, you can go and select any countries that you want. So right now I have several countries selected, and if you wanted to compare, just tick it off, and then what you see is this, it'll add on this country. Okay, and if you don't want it anymore, don't delete it or anything, but just go back and uncheck it. So I'm going to do this for Austria, and let's see what happens. Okay, so I have my date here and I have my total cases. Okay, so I'm gonna build my graph. So what we're gonna do is we're gonna select both of these columns, and after this, if you go to insert, and most of you perhaps already know how to make a line graph, but never mind. Okay, so what I have right here is this is my Austria total cases. Okay, so it's not completely unlike what Grant had in his video, right? So what we can do from there is you can see that it's going by every 3 days. That's only because my x-axis is squished. I can assure you that it does indeed have every day in there. Okay, so before we do before we find the growth rate, let's just quickly take a look at what we could approximate the inflection point to be. And if we look, remember, we're looking kind of at this halfway point where maybe the slope is exactly 1, so maybe something like this. If I click it, select all of them, I'm going to click again, and it seems to be, I don't know, so this is March 27th. So we'll see if this is significant in any way. Here we go. So what are we going to do now? We are going to find the growth rates. And so remember, first we need to do the difference in the total cases, right? The new cases. So we're going to do our equal sign, and we're going to say, hey, give me my total minus my previous day's total. Okay, and then if you hover over until you get this skinny little X and drag it down, then you see that you have the difference between this day and the day before. So this is how many new cases there were. Okay, now looking here, we can see that this is an anomaly. If you average these two numbers out, then you would have quite a smooth progression, right? So what must have happened here is perhaps some sort of an administrative delay where a whole bunch of these people got registered on the next day. That's what real life data does, right? It's not that straightforward. By the way, these gray rows here is just the weekend. I've seen some data where on the weekend the total number of cases all of a sudden falls, and that's basically due to perhaps the processing being done on Monday, Tuesday, or just things being quieter on the weekend. Not as many people maybe bothering, but staying, yeah. So, but it doesn't seem to be very significant for Austria. Okay, so we now have our new cases, and where is my graph? There it is. It may take a moment to pop up. Don't worry. Okay. And so now I'm going to find the growth rate. Okay. So what we're going to do is I'm going to start here because I don't have anything above, and I'm going to say, hey, can you take my change in cases on today divided by yesterday? Okay. Now at first, of course, he's going to freak out a little bit. He doesn't like to divide by 0. No one does, but we just need the formula to be applied throughout. Okay, so here we go. Okay, so these are your growth rates, okay? So you can see that here the growth rate is consistently over 1. Maybe not here, maybe again got processed somewhere later. And then where are we at 1? So we're at about here, we're at 1. Interesting. Remember, I wanted to see whether the 27th was some sort of perhaps a point of inflection, right? So here we are. And the day before, this was that crazy day. This is some sort of, these are outliers, okay, that have some other factors. But look what happens at around this time, right? You've got 0.9, and then you've got 0.5, 0, 0. Okay, this one is 1. But the rest of these pretty much, unless it's just slightly over 1, well, this one is a little bit more. But here we are. So you could say that this is on the later part of the curve, right? You can see these are the growth rates that he was showing in the video that are flatter. The slopes are flatter, okay? The orange row here, by the way, is when Austria went on shutdown. And so you can see that as soon as the country goes on shutdown, it doesn't necessarily happen immediately, right? You're still sort of over 1, but you could see that somewhere 8, 9, 10 days later, things are starting to take effect. Okay, so this is all you're going to be asked to do in your assignment. Just build a graph for the countries that you'll be requested, and just see, can you approximate the inflection point? Can you find the growth rates and just see what's happening? Okay. Just before we end, there's a couple of other things that I wanted to quickly show you Excel-wise. And one of them is maybe you want to not look at the graph for the total cases, but you want to make a graph for the new cases. So you may be wondering, how can I graph the first and the third column? What you want to do is, once you have made the graph, and I repeat, after you've made the graph, if you're just trying to select it, it won't work. Then select the 2 columns, and then if you move over here with the hand and just go over, boom, what you have now is these are now the new cases. And in fact, you might actually even want to graph the growth rates. Also very interesting, right? There's all of these outliers, but if you do a running average, then it does get smoothed out. But never mind that, okay? So I'm just going to go back here. And then the other thing to show you is maybe you want to compare another country. So what I'm going to do is I'm going to take a look, well, what happens with the states in comparison, right? With Austria. Okay, so I'm going to do this here. Okay, I'm going to insert my US. So now I've got my US, and I'm going to say, hey, I want my US with it. Okay, so I've got my 2 columns. Okay, and then if I now graph this, so I'm going to actually get rid of this graph. Oh yeah, here it is. It has to be highlighted. Oops. It has to be highlighted, okay? Then now we can just drag this over. Do you see I used the corner? Now all 3 are selected. And what it does is he ends the US. And you can see where we're at. This is being done on April, this data is up to April 12th, right? So Austria and the US, okay? Last thing, so that's a little bit for you to play with. Last thing I wanted to mention that you may have heard in the news, and that is what they sometimes refer to when they talk about the growth rate. They talk about the doubling rate, okay? And I wanted to show you my Austria, and that is basically how many days it takes for the number of cases to double, okay? So if I go here, this is Spiegel, and if you go down here, this is just an example of this doubling in context. Then Verdopplungszeit, so doubling the time. So this is how many days it takes for a country to have double as many cases. Okay, so you can see the US, it's doubling every 10 days. And is Austria here? Yes, there it is. So Austria is now it takes 35 days to double. Okay, now of course, the bigger this number, the better it is. Okay, and if you wanted to calculate it, or just you could just look at it basically, right? So you could basically say, okay, here I'm at 15, and then here I'm at 30. So on February 21st, the American doubling rate was 8 days or whatever it is. Just see where it is double. Okay, so that's all for today, and I hope that you learned something and that you will apply it successfully. Bye.